Hello UniPlot community. This video is the first part of a webinar we gave regarding UniPlot being used as a post-processor for virtual dynamic. The teams of both software worked closely to bring you this introduction.
Hello everyone and welcome to our webinar today, Virtual Dynamics with UniPlot as post-processor. Virtual Dynamics is an advanced multibody simulation software, and UniPlot is a dedicated tool that enables us to visualize and analyze data. Intuitive analysis of data, intelligent checks, and automated reporting are the golden solutions that every engineer and every manager is always looking for. And with this webinar, we will try to showcase some of the possibilities that we provide with both our tools. My name is Swapnil Shah. I am the product manager and the business development manager for Virtual Dynamics and UniPlot respectively at FEV. I will be the moderator of this session and I'm joined by my wonderful colleagues Prashant Mane and Atrian Lavo. Prashant is our senior application engineer for Virtual Dynamics with multi-body dynamic simulation experience of more than 10 years and a user of Virtual Dynamics since 9. Adrian is our product manager for UniPlot with background in mechanical engineering and 8 years in internal combustion engine calibration. He is very passionate in finding out new ways of improving data analysis of UniPlot for all kinds of application, and today he will be focusing on multi-body simulations. In today's webinar, Prashant will get us rolling with an introduction to Virtual Dynamics, the transition of the results to UniPlot, and its basic functionalities. This will be followed with a live demonstration of some advanced plotting and reporting features by Atrian. The final part of the webinar will host a Q&A session. Therefore, during the demonstration and the live Q&A session, please use the side menu to forward questions about the products and the content shared today. With Adrian and Prashant here today, I'm sure we will answer them all for an engaging discussion. Thank you again for joining. Prashant, over to you.
Thank you, Swapnil, for the introduction. Welcome all from my side, and thank you for joining today's webinar. So the agenda for the webinar consists, I will provide the introduction to Virtual Dynamics and UniPlot, followed with the demonstration of some basic data analysis using UniPlot, the overview of advanced functionality, automation with sequencer, and finally sum it up during our question and answer session. What is Virtual Dynamics? So Virtual Dynamics helps the user to create virtual prototypes of components, subsystems, assemblies of engine, transmission, and driveline assemblies. This, when coupled with virtual test bench, helps us to carry out virtual testing in mechanical dynamics domain. Fields of application of Virtual Dynamics is vast. It provides wide range of solutions for analyzing electric motor, hybrid, crank train, wall train, transmission, full vehicle level analysis, the continuously variable transmission. Virtual Dynamic can help a daily user to address typical challenges he encounters during the durability or NVH like investigations, wear investigations, driveline dynamics. So virtual dynamics can be a good tool to help him find the answers. Moving on to UniPlot. So UniPlot is a dedicated tool that enables us to visualize and analyze data with the help of advanced graphics capabilities, fast creation of high quality reports. Also, it has a advanced coding module that can meet the user's need based on their requirement. UniPlot is intuitive and a structure process which helps in data analysis. It consists of structured steps wherein at the first level data can be imported from different types of database and raw data. Then in the second step, we can create template using helpful features like automatic headers, different types of plot, different types of table over here. And also it has various tools and filters which can be used to analyze the data more effectively. Finally, once we are satisfied with the analysis, we can export the result to a PDF or a presentation template. UniPlot can also do more in addition to the regular 2D graphs we see. It can help us to create our 3D diagrams, orbital plots, FFT spectrograms, waterfall diagram, and as I mentioned that with Uniscript, we can have our customized scripting as required. With this, let me switch to the live demonstration where will we further continue. So let me open a virtual dynamics session over here. Now let us see how we can access UniPlot in virtual dynamics session. So currently I am in a standard interface mode, and UniPlot option is available under review over here, or else we can use an shortcut key of F10. UniPlot is embedded into Virtual Dynamics installation package since 2021 release. Hence, the compatible UniPlot version will be installed automatically during the Virtual Dynamics installation. Please note that this embedded version of UniPlot is only available from Virtual Dynamics interface and cannot be opened as a standalone software. To move with UniPlot, we will first require to generate an example request file. For UniPlot, the input is really independent of model or analysis type. For this webinar, let me use the crank-train inline 3 assembly from our model library. Let us create a request file. I have considered crankshaft RPM to be 2000, and let us run it for 5 cycles, the simulation. In this example, the size of the request file will not be too big. However, UniPlot can import multiple files with which can run into GB. Let me also run the simulation for another boundary condition. Let us say constant velocity of 3000, which will help me later to demonstrate a very useful data exchange functionality in UniPlot. So let us switch to UniPlot using the option. Before I introduce you to the UniPlot interface, let me first import the file generated in our previous step. So with import, let us import the request file over here. Under tools in add-in manager, we can select virtual dynamics request file import. Once this is activated, we will be able to readily read the REQ file. So once the file is UniPlot automatically converts the R request file into the UniPlot compatible NC2 file. Here we can see all the requests and their components are grouped together. The UniPlot interface is intuitive and contains clearly marked areas. The organizational structure consists of pages and plots, just like the standard post processor. Different plot layouts are possible in a single page or multiple pages. A menu bar with all extensive functions is visible on the top. A quick toolbar is available. It contains many familiar tools for actions like file and text editing. It also provides many special plot manipulation and editing tools, which can be considered advantageous. On the left side, we can see the data browser. Here on the top, we can see the current request file read. Then we have different types of plots available. Here are all the results under all channels. A preview window provides a valuable insight in selecting the correct data to plot. It is possible to import multiple request files in data browser simultaneously and switch between them for plotting different results. Clicking on edit will take us to the imported request file in tabular format. This is a powerful tool with many data handling possibilities, including filtering, sorting, performing complex mathematical functions. In addition to the readily available standard results, we can also generate additional requests. Let us create a new channel for calculating velocity of main bearing 1. So the tool has its memory. So it has, before our webinar, I had run through the tool, and here we can see that it has stored the previous information. So we add a channel called MB1 velocity. This column is then automatically added. Let us see we can edit the formula for this channel. So the functions as well as the function channel can be selected from the drop down menus and don't have to necessarily be written manually. Let me re-enter the formula over here for the velocity. This will calculate the magnitude of displacement and differentiating it over time to get the velocity. These manually created output channels like MB1 velocity will now be available in the group results under all channels. Let us now have a look at the general plotting actions. As I mentioned that multiple pages and different types of pages are possible in a single document. It is possible to plot the data in multiple 1D, 2D or 3D diagrams. Before we start, let us have a look at the global settings also. The global settings gives consistency in plotting and saves a lot of manual effort in updating each plot individually. Almost every possible parameter of a plot can be set here. Let us now select the plot type to be 2DXY. The same process can be followed for another type of plot. If the page is selected, like right now, if the page is selected while clicking on the load, then a new separate diagram will be formed. This new diagram can be moved up or down using the cursor keys. Adding a curve to an existing diagram is also possible. We have to select the existing plot and then let us plot. Both the diagrams will be merged into one and a new y-axis will be intelligently created if necessary. To edit or delete any data, we go to data list. And we see we can format the curves as desired. We can even delete it from data list. UniPlot also supports the drag and drop option. So I will quickly highlight that feature as well. It is possible to resize the diagram using yellow and blue squares. So you can resize it as desired. And the drag and drop method is also helpful in plotting multiple results simultaneously. So we can change the overall look. Then under edit filter functions and append filter functions, there are various filter functions which can modify our current curve based on the applied filter. Now that we had a look at the standard graphs, let us now move to another type of plot. Let me change this to 2D cycle. This option lets the user decide the length of the cycle and also select which cycles to plot. You might recollect that during the steady state analysis, we had set the cycles to 5. Also, for the orbital plot, the square shape is more suitable. So let me again set the values. And let us now again select the MOFT plot. Here, as I mentioned, that let us select 3 and 4 cycle out of our 5 cycles we run from 0 to cycle length of 720. Now we can easily create a polar plot using the option display as polar plot over here. Let me also add another plot. There is another option in the quick toolbar wherein you can directly select this option to get the polar diagram. We can scale the current Y data, which is in mm to microns with multiple options. So select the curve in properties. We can change the Y factor to 1000. Or else you can again select the curve, and in the edit filter, we can provide the necessary information. So let me scale this plot as well. I will edit it to 1000. One of the ways of configuring many curves simultaneously is axis linking. So we have this function in UniPlot where we can link the axes of different plots. And here, now the axis configuration of only one plot needs to be done, and the changes are updated in all the diagrams. Let us now move on to the demonstration of a magical feature of UniPlot. UniPlot recognizes the requirement of consistency and to avoid repetitive manual work due to repeating diagrams and reports in a single as well as over multiple projects. Hence, it provides many different solutions to assist this action, and data exchange is one of them. In the dialog box, the name of the currently used data file is displayed. This dialog box shows all the active channel in our document. Any individual channel can be edited using the edit channel option. The compatibility is displayed under the valid column. Plus sign indicates a valid channel, whereas an exclamatory mark indicates a non-existent or a faulty channel. You might recollect that I had run additional iteration for steady state analysis for 3000 RPM. So let us replace the current 2000 file with the 3000 RPM file. The options dialog box will prompt you to manage the parameters of the data exchange process. Now all the plots will now be updated with the channels from the new request file. This provides you the flexibility of preparing standard templates, which just need to be updated with the latest results based on multiple boundary conditions investigated. This saves a lot of repetitive tasks, and we are much faster in comparing and analyzing the results. The template can also come from some another projects. This now brings me to the end of my session. Since I wanted to introduce general data analysis I considered a simple example of 3-cylinder inline cranktrain model available in our model library. In the next segment, Adrian will demonstrate the advanced functionality where he has received input from such a complex model as seen here. This is a two-stage electric drive unit consisting of flexible e-motor housing, gear housing, shafts with roller bearings, e-motor, revenue planetary gear sets. I will now hand over the session to Adrian, who will take you through the advanced functionality. Over to you, Adrian.
This is the end of the first part of the webinar. Watch our next video to see the advanced application of virtual dynamic data analysis in UniPlot. Thanks for watching us. For any question, contact us at support@uniplot.com. Come and check our website www.uniplot.com and click on the logo to follow us on LinkedIn and get fresh news of UniPlot.